Okay, so in this video I'm going to be going over what I call the design flow for printed circuit boards. And it really starts with schematic capture, which you've been already working on. And part of the process of designing a schematic is then to do checks. And so it's kind of an iterative process where you're going to go and check and see, is everything okay? Is everything correct? You run the ERC, for example. You've got to visually check it compared to the original schematic you're working on. And so you're going to kind of go back in this process of going through it a few times until you check and make sure everything's correct. And one of the points that's super important with this is there's a lot of process steps before we actually get the circuit board manufactured. And if you have a mistake in your schematic, you could have a circuit board that looks beautiful when it's done, but if that error exists in the very beginning, it's going to propagate all the way through. So quality assurance or quality control is super important all the way through the circuit board design process. So once the schematic is correct and everything looks good, then the next designing the board, laying out the parts on the board. And again, now in this case, we're looking at DRC, design rule check, but there are a number of other things too. For example, we might have to check the dimensions for holes. You might have to work with a mechanical engineer to determine the shape of the board, cutouts, all sorts of other things. So it's not just a one-person job. Usually if you're designing a circuit board, it's something that you're working with other people on to find out what the criteria are. But the idea, again, is that you go through a process of design checks. At some point, you might even have to actually loop all the way back to the schematic in case, for example, a component isn't the right component or the wrong size. You might need to modify that in the schematic. So next step after that is once the board is done, we're going to go through a CAM process. And in Eagle, we haven't talked about this, but I'll go through this in probably the next week or two, is computer-aided manufacturing process steps from the board to create a number of fabrication files. So I'll call these fab files. Now in this unit, I'm going to talk about some different file types, and I'm going to write these out real quick. So the fab files are broken up into two different types, Gerber and Exelon, both named after manufacturing companies, and you'll learn a little bit more about that in the PowerPoint and the videos. So Gerber files basically define the traces and pads. So on the circuit board, for example, that would define where the pads are, where the traces are, their locations, that kind of information. The solder mask, which is basically the green covering which masks everything except the areas that need to be soldered. And then the silk screen, which is the nomenclature, part numbers, values, any printing that you want on your board. That's usually the white layer that you see. The other main type of files are Exelon files. And those basically define the drill tool sizes, so the diameters of the tools or the drills. And then the hole locations, which are essentially the X and Y locations of all those holes. Now, once those files are generated and created, they're basically emailed or sent to what is called a board house. Sorry, it looks a little bit messy. Okay, and so the board house is going to take these fab files and they're going to modify them probably a little bit for the manufacturing that has to be done. And then there are all these manufacturing steps. And these manufacturing steps are what we talked about a little bit last week, from working with the photo tools, but then all the different manufacturing process steps. So this is really what we're going to be kind of talking about this week more than anything. What I want to try to make sure you understand is that the design part that you are doing and are involved with kind of goes up to this point here. And then the boards are being manufactured. So that's the difference between the design side and the manufacturing side. So and there are a lot of steps to manufacturing a circuit board, something like 100 different individual steps. It's not the kind of thing you can do in your garage typically. It requires very specialized high-end equipment. So once the board is created, though, it's manufactured. They're often in these manufacturing steps. They're doing all sorts of fabrication processes, but usually at the end there's some testing that's done. And then once that testing is completed, they ship the boards and they come back to you. Here you are, the circuit board designer. And then the next step is actually going to be soldering the components and then testing the final product. So when it's all said and done, you have a finalized circuit board. So it's important, again, to understand the quality processes that go into this. When a board house gets these files and makes a circuit board, not all of them make it all the way. Sometimes there are errors. And so, again, there's any possibility of an error occurring through this whole process that could cause a problem. But because the board house at that point is in control of all the manufacturing steps, they also typically have to do some kind of testing. The circuit boards that you ordered are both visually and electrically tested, which is pretty unusual. But there are ways to electrically test the boards, and we'll talk about that probably in the next few weeks. So that's the end of this little video. I just wanted to kind of talk about kind of like the difference between the design and the manufacturing process steps. And when you watch the videos, all those videos are going to be focused on this part here, the actual manufacturing. They're getting your data and manufacturing it and finally fabricating a circuit board.